Hey, what's going on, everybody? My name is Eric Bodeker. I just graduated from college with my bachelor's in science and exercise science. Welcome to my first YouTube video. Today, I want to go over the fundamentals of a strength training plan for an athlete. Um, so let's just dive right into it. So, so for some basic terminology, we wanna have a few things under our belt or understood so we can assemble a new plan. So for our first definition here, we have a training session. This is going to be our workout for the day. An example of this could be a lower or upper body day. So like a lower could be anything lower extremity. This could be squats, leg presses, lunges, as etc. For upper body day, this could be like a bench press, shoulder press, anything involving the upper extremity with an upper extremity focus. Next, we have volume, which is our weight times our sets times our reps. So, say if I went and squatted 100 pounds for 3 sets of 10, I would have a 3,000 pound volume move for the day. Next up, we have microcycle. A microcycle is pretty much just a week's worth of workouts. So, if you train 5 days a week and you go Monday through Friday, that would be one microcycle or 5 days for the week. Next up, we have mesocycle. This is a phase of training that usually attains a specific goal, usually about a month or so in length. So when assembling these, we can have a certain goal attached to it, such as like a hypertrophy focus or a strength focus. Like we said, this is usually about a month or so in length, provides enough, usually provides about enough time for an adaptation to occur, and we can build off each, pretty much each phase into different phases that eventually produce a goal. And then next up, we have our macro cycle, which is a phase of training that usually lasts about 1 year. This is also referred to as like a yearly plan of action. It could be a season for a sport. So, say if like you're a football player training for like the national championships, your macro cycle is going to be tailored from your off season all the way leading up to your a hopeful championship or successful season. Usually represents a long-term goal or plan of action. Now it's not shown here, but another term could be an Olympic cycle. An Olympic cycle is usually four macro cycles strung together. It is pretty much training an athlete for Olympic level competition and hopefully placement or higher placement in the Olympics. So moving on, a few things that we want to take into consideration when programming for an athlete. We want to find out what are our needs, what exercises should we do, what are our volume loads and frequencies, and what are our exercise orders. We want to have all these down before we start assembling a plan. So, so for our needs analysis for strength training in regards to an athlete, athletes may have different needs than an individual just getting back into shape. So if someone usually works at like a desk job, or if someone is usually sitting most of the day, they're gonna have different needs compared to an athlete who is training or who competes for either their college career or for their lifetime career. There's gonna be different needs based on each individual and what they do. We want to understand the biomechanics of the sport being played, and we want to build exercises around where the athlete struggles or needs development. We don't want to just assign a random exercise plan for a baseball player when they play, lacrosse. Every sport's going to have different biomechanics, and they're going to be played differently and have different stresses and strains on the bodies, and we want to be able to take those into account. What are some common injuries and how can we reduce them? Athletes in different sports might be prone to different or various injuries. An athlete who plays soccer or lacrosse, right? If or basketball, if they're cutting all the time, they're gonna place different strains on their body compared to, let's say, if you went golfing, right? One of them utilizes a little bit more upper extremity in regards to trunk rotation compared to, let's say a soccer player who's utilizing a lot of lower extremity might be more prone to ACL tears compared to someone who utilizes much more of their upper body and torso up here, right? So where does the athlete lack ability, and where's their current standpoint physically? What are the strengths and weaknesses? We want to take everything into account, right? So in terms of their ability, how high can they jump, or what is their current athletic ability? We want to take everything into account. What is the current standpoint, right? Are they physically strong already, or do they need to be developed further? What are their strengths and weaknesses? We need to take everything into account. How long has the athlete been training for? We're not going to assemble the same plan for somebody who's been training 6 months compared to someone who's been weight training for several years, or an athlete that has been in their sport for a long time compared to someone who's never played this sport before. Well, if you're an athlete in the sport, I'm assuming, I mean, we can't always make assumptions, but I'm assuming that you've been playing the sport for a little while now. But like we said, we can't always make assumptions. But we need to figure out how long the athlete's been training for, and this will give us a good perspective on how we build their plan out. In terms of, did I skip one? No, cool. So in terms of exercise selection, sometimes sports require a high power output from athletes. So our power is referred to our energy over time. So a good question is, how can we speed up the athlete with weights? So if we take into our account our Olympic weightlifting movements, such as our power exercise, such as the snatch, the clean and jerk, and their derivatives or variations, these are great options for developing speed within the athlete. If we take into account core exercises like our bench presses, squats, deadlifts, and overhead press, these exercises are usually done a little bit slower. They have great adaptations in neuromuscular strength, but we're looking for higher speed and higher force output movements. We're going to get higher speed and higher force output out of our snatch and clean and jerks due to the time that they're spent completing each repetition and the force that they put into the ground. You're not going to get you're not going to get a quicker time performing a slow movement like a squat compared to a clean and jerk. And then we have other exercises such as like assistance exercises or possibly associative. These exercises are usually done to bring up lagging body parts, work on injury prevention, or unilateral stability. So if we look at like a lunge, for instance, we're building up unilateral stability. So this could be working on possibly one limb has a deficiency compared to the other limb. That's what we could be using lunges for. Also, they're great with injury prevention. So if we need to build up restraints against, let's say, like ACL forces, we will be working on unilateral stability to be able to build up a good tolerance in resisting those forces. Dumbbell bench presses, these are good exercises to build up, upper body strength, good way to complement the barbell bench press. Rear deltoid exercises, if the athlete is, usually working in their sagittal plane here, right? We'll be working on rear deltoid exercises to help complement their overuse in their sagittal plane and their pushing movements. So for baseline testing, we want to test the athlete with the least fatiguing to most fatiguing movements. So a good protocol could be like our first test could be a skin fold measurement. So this could be like, we could get calipers and we could test the thickness of their skin. Good way to assess body fat, like a DEXA scan, right? Moving on, we can go into agility and change of direction tests. So the main difference between the agility and change of direction is agility, the athlete doesn't know where they have to go during the drill. They're giving audible or like physical cues, such as like pointing in a certain direction. It's a form of stimulus that is a little bit more, that makes the movement or the exercise a little bit more difficult than the change of direction. And change of direction, the athlete knows where they have to go. So if we look at a T-test, right, and the athlete knows that they have to run up and either possibly run left or right. If we look at if we make this more of an agility test, the athlete can run at the coach, and the coach could instruct them, okay, turn left. They don't know which way they're going to go at first, but we add that audible stimulus and we make it a little bit more taxing, but also, a little bit more, it'll be a little more taxing, but it might be more beneficial to the athlete, like within a game scenario. Next up, we have maximum power and strength tests. So maximum power, this could be our weightlifting movements and the derivatives, such as like a snatch and a clean and jerk. And then our strength test could be like our squats, bench press, and deadlifts. We have sprints after this. We might be a little confused with this. The only reason one of the main reasons why sprints are after this is because not only are they high velocity, but they also have some of the highest amounts of forces placed on the body. If we look at the ground reaction forces, like in Newton's laws, we'll see that the sprints may have up to about 10 times the body weight and forces placed on the body. It's higher than a strength or power test or strength or power movement. And so therefore, sprints are usually very high in intensity, and they really are only done a few times during the week, maybe like once or twice, depending on the athlete's, ability to tolerate the stresses. Next up, we have local muscular endurance test. So this could be maximum push-ups, body weight squats, or crunches to assess trunk stability through either trunk flexion or trunk extension. And then to finish off, we have max aerobic capacity tests. So we could do like a Wingate bike test, a great way to measure VO2 max. If you ever done one of those tests, that they're pretty difficult. But so as we can see here, we're going from least to most fatiguing for our testing battery. So that's the way we usually want to assess our athletes. Moving on, we have volume and frequencies. Volume, like we mentioned earlier, is our weight times our sets times our reps, and then frequency. So frequency is referred to how often exercise or muscle group is targeted throughout the week or during a training cycle. So if we have an athlete bench pressing Monday and Thursday, they have a 2-time-a-week frequency. We can increase the frequency here or decrease it, but we have to make sure that the athlete can tolerate the level of stress of their training here. So how often should an athlete train a muscle group? Athletes should be training as often as possible, but without interruptions within their recovery resources. So it's very difficult to cut back on volume. So adding in small amounts of volume with time is the best option. The last thing you want to do is to, write down for an athlete or have someone perform multiple sets of multiple reps, the first day and get, soreness is not always, going to be the best indicator of growing muscle. That's for another later topic. But if we jumpstart them on extra amounts of volume and they're not able to recover sufficiently, we may have to drop back on volume. And the only time we really can drop back on volume is during a deload, right? A deload is another topic for another video as well. But at that point, we're going to have to deload and then we're going to have to restart another training block. And at that point, we've missed about 3 weeks worth of training. If you think about it that way, we've almost missed an entire mesocycle worth of training that we can progress the athlete with. So we want to start lower on volume and then progress over time as the athlete adapts to the stress of training. So what are the training status, right? The more experienced the athlete, typically the more volume that they can handle. So if an athlete's been training for 6 months, they're going to be able to handle less volume compared to an athlete that's been training, let's say 4 years, right? This also takes into account, like if an athlete were to do sprints, some athletes may be only able to tolerate sprinting 1 time a week, maybe up to twice, maybe, but more well-trained athletes are going to be able to increase the frequency on how often they do these sprints or how often they exercise or lift throughout the week. So we want to take into account their training status and experience. Next up, we have sporting demands. So we want to take into account what training season are they in? Are they in their off season? Are they, about to compete? Are they in their championship? Like we need to figure this out because we don't want the athlete to be too sore or beat up before their competition. So the off season is typically a time for more volume. This is sometimes referred to as GPP or general physical preparedness. So at this point in time, we're going to keep the volume high, but we're also going to drop the intensity, and we're also going to have low specificity when it comes to the exercises, right? We're not going to be the program is going to be entirely tailored to, the exact sporting demands of what the athlete is going to encounter. However, we want to build up muscular endurance, build up muscular resistance to fatigue, and just add on more tissue to more muscle tissue for the athlete so they're able to handle greater demand of training and handle greater demands for their sports. And then as we progress on in the season, it's gonna become more of an inverse relationship. So the intensity is going to increase, but then the volume is going to decrease. And then once we get closer to the competition, as we see here in the next one, the training loads, right? Heavier, we're going to be training heavier closer to competition so that we maintain our nervous system adaptations to heavier weights. However, we can also include a power focus in higher competition. So if we don't want to train the athlete at, let's say, 85% for sets of 2 or 3, right, or even sets of 4, we can include higher velocity movements so that the athletes can mimic this within their sport. I think peak power if we look at a force velocity curve, I could be wrong, but I think a peak power is usually 30 to like 60% or so of like a 1 RM of the athlete. Mostly just looking at the trajectory of how fast the bar can move. That's what we want to focus on so that we can better mimic their movement in competition. And then other training variables, we want to include their training stresses from practices in their game schedules. The last thing we want is for an athlete to be too beat up by the time like the biggest competition of their season comes about. It's the last thing we want. So we want to make sure that the athlete is well recovered, but they're also still getting the benefits of training and still have the neurological adaptations from their training from beforehand. And so they can build upon that for either the next season or so that they can just maintain it going forward. And then I believe this is the final one. We want to take into account exercise order. So we want to start with the heaviest and most neurologically taxing movement first, and then we want to back off to our accessory movements. So for an example workout, we have the back squat, the unilateral lunge, and then the leg extension. Back squat is great because it's a ground-based movement, right? And it provides lots of neurological and strength adaptations or muscular adaptations for the individual because we can load it very heavily and it's axial loaded as well. If we look at a unilateral lunge, this is also great because we can focus on one limb at a time if there's a possible deficiency within a limb. And since it's unilateral and it's one limb, if we want to focus on one and build up like resistive forces when they go play in their sport so that they don't get injured as much, this is a great way to complement not only our strength but to prevent possible injury. And then last we have our assistive exercise. We can do like a leg extension. This is a single joint exercise, so this is going to isolate usually one muscle group at a time, and this will be there to complement our compound or multi-joint exercise such as a back squat. So while prepping for sport, we want to include power cleans and snatches before squats, just due to their mimicking abilities of the sport through the stretch shortening cycle and triple extension. If we look at the stretch shortening cycle, right, we have the double knee bend within the snatch and the clean and jerk. This is often carried over during sporting mechanics to almost all sports, and same thing with the triple extension. It's a very athletic move. Like if you look at the NFL Combine, a lot of these athletes are being tested on their vertical jump ability. So this has a great carryover to sport. If you look at the vertical jump, all these athletes are going through triple extension, and they have included double knee bend, or they bend their knees before they go and jump up to touch the rings. So this includes the stretch shortening cycle. So that is why we would want to include power cleans and snatches as part of their programming, because it mimics most sports and has a great carryover to pretty much all sports. And then weightlifting and powerlifting movements. So weightlifting, like our snatch and clean and jerks and their derivatives. And then the powerlifting movements, such as the squats, bench presses, and clean and jerks, and ground-based movements, provide some of our greatest adaptations due to how heavily we can load the object or load the barbell, how well it develops the nervous system, how well or how it like works the muscles or packs on lean muscle tissue, and it's multi-joint cooperation. So we want to focus on these movements so that we can build the athlete into a better athlete in general, and it will prepare them more physically for their sporting demands. So I believe this is the end of the slideshow. I want to thank everybody for tuning in. Please like, comment, share, subscribe. I'll be posting more videos and I'm excited to keep going from here. So thank you guys for watching.